Welcome to clickmyproject.com. Our title is Scalable Daily Human Behavioral Pattern Mining from Multivariate Temporal Data. Our abstract. This work introduces a set of scalable algorithms to identify pattern of human daily behaviors. These patterns are extracted from multivariate temporal data that have been collected from smartphones. We have exploited sensors that are available on these devices and have identified frequent behavioral pattern with temporal granularity, which has been inspired by the way individuals segment time into events. These patterns are helpful to both end users and third parties who provide services based on this information. We have demonstrated our approach on two real-world datasets and showed that our pattern identification algorithm are scalable. This scalability makes analysis on resources constrained and small devices such as smartwatches feasible. Traditional data analysis systems are usually operated in a remote system outside the device. This is largely due to the lack of scalability originating from the software and hardware restrictions of the mobile wearable devices. By analyzing the data on the device, the user has the control over the data, and that is the privacy and the network cost will also be removed. Uh, the computing and networking capabilities of mobile and wearable devices makes them appropriate tool for obtaining and collecting information about user activities. This has led to significant expansions of opportunities to study human behavior ranging from public transport navigation to well-being. Moreover, the advent of mobile and wearable devices enable researchers which identify human behavior to an extent that was not previously possible. Nevertheless, there is still a lack of wide acceptance of mobile sensing applications in real-world sensing. There are different reasons for this mismatches between capability and acceptance. First, the limitations of resource and the lack of accuracy in the collected contextual data, especially, is a challenge with regard to a battery life. Furthermore, the small size of the sensors that are dealing with radio frequency, that is Bluetooth, Wi-Fi, and GPS, affects the quality of their data. Um, for instance, visualize two data of the datasets uses as it can be seen the local locations. Wi-Fi data and other data objects are not available at all the time. The next reason is the proximity of the smartphones to the user, because these devices are not always carried by the owners. However, smartwatches and wearables are body mounted, and thus the proximity problem is less challenging. Lastly, the operating system restrictions of mobile devices, which removes background service when the CPU is under a heavy load. As a result, there is no ideal data collection approach that can sense and record individual information 24/7 with no data loss or uncertainty. Existing work that support mobile data mining have offered very promising results. However, these studies employ specific hardware which is known for data quality among users, or they analyze data offline outside the device. We believe there is a lack of scalable data mining methods that can handle the uncertainty in the work. We introduce scalable algorithms that utilizes a variety of sensors like Wi-Fi, location, etc. By leveraging collect multivariate temporal data, our algorithm can identify frequent human behavioral pattern with a time estimation similar to the human perceptions of time. We have tested our algorithm and their scalability on two real-world datasets and two small devices, that is smartphones and smartwatches. Identifications of frequent pattern in human behavior has applications in several domains, which vary from recommendation systems to healthcare and transportation optimization. For instance, a healthcare application can monitor a user physical activity routine. However, if there is a change in their routine which is not recognized or not notified by the user, then the system can recognize this and the notify care givers about the change. Another use case can be transportation optimization. This is our project flow, or named as system architecture. In this, first we will be having a login, then we will be having uploading datasets. The datasets which has the common human names and with their behaviors, and we need to pre-process the dataset. So we are pre-processing dataset for getting original information from the dataset. Then we are processing the human behavior which is being given in the dataset. Then human behavior has been processed by the scalable algorithm. Because of the scalable algorithm, we can able to match the human behavior to the information which they need to be accessed, so that the information can be protected from the third party or an unauthorized user. Then finally we can able to get information access from the user. Let's see our project. Just click on a home and right click to run. You can able to get our first screen as a scalable daily human behavioral pattern mining from multivariate temporal data. I just start the project. In this I can able to get a data set screen. In this we can able to upload. Just uploading, I will just upload the data set of human behavior which I have open. Then we need to view the dataset. Dataset loaded successfully. The dataset is been loaded in a database for processing purpose. Okay, we can able to view our dataset which is been get loaded in the database. Then next step is to pre-process the data as I told in a flow. In this we need to pre-process successfully. Okay, then view. After pre-processing, two informations detected. Okay, you can able to see the two informations of the dataset. Next, in this we need to sign up or log in. For a new user we need to sign up. I just sign up with a name of James, and email address I just give it james@gmail.com, and password is also James. Get started. Register successful. Okay, and login. In this I will give a James, and the password also James. Log successfully. Log successfully. Then you can able to get a screen of behavior matching, which is known as username. In username I will just give a James, and in a behavior I will be giving crying as a behavior, because I have these in a data set, right? See, I have a James and crying as a behavior, so that I will be giving these two. I need to open some information from my file, so that I will be clicking text, etymology.txt. In this, after getting, I will process behavior matched. Else, if you doesn't give a crying, instead of giving a smiling for that, you will get your behavior doesn't match. I think you are not a valid user to view the information. In this case, you cannot able to view the information which is being given by the user, right? Only if the behavior matches you can able to get the access information box. Just click on information. You will be able to get the information which is being protected from the third party user or unauthorized user, so that information protection can be able to achieve. Then you can able to give a behavior prediction. In this behavior prediction we will be giving a graph model. In this you can able to view how many behaviors have been viewed over informations. In blushing has viewed 22 times, crying has been 6 times, and hand motion has been 12 times, and hiccuping has been 18, sleeping has been 12, smiling has been 2 times. These are the users which have used their behaviors to view these informations. That's all. Thank you for listening.